Hello, and welcome to Sets and Set Operations. My name's Tuesday Johnson. Here's an introduction to the concept. First of all, we talk about a new item in math. We should look at terminology and notation. A set is a collection of items. That's all. The items in the set are referred to as elements of the set. For example, if we wanted to write the set of all colors of the rainbow, red, orange, yellow, green, blue, and violet, we might write it like this. I use purple instead of violet because my daughter's favorite color is purple, not violet. So when we write sets, we generally use a capital letter in order to name the set, and then we use braces. Also, I'll sometimes call them squiggly brackets because I'll forget the word braces. Braces enclose the set, and then the elements are always separated by a comma. All right. Let's take a look at this same set, right? Set of colors of the rainbow. We would say that green is an element of the set R. So green, and then this funky little E symbol, it is an E, it's for element of, and the set R. However, teal, right? Teal is not listed up here. So teal is not an element of the set of the colors of a rainbow, so we would say teal is not an element of R. A line through it means not, and we could have not equals, not an element of. We see this idea of not mathematical concept frequently. So if a set A consists of colors of the American flag and the set F consists of colors of the French flag, we would say that A and F have the same elements, regardless of order. And so A equals F. So we generally say in the United States, red, white, and blue. But in France, they say blue, white, and red. It doesn't matter what order the colors are listed in. They're exactly the same colors. All right, if our sets are not equal, so they do not consist of the same elements, we may have a different type of relation. The set B is a subset of A if every element of B is also in A. Notation for this looks like a little C with a line under it, and the C really does mean like contained in, right? It's everything in B is contained in the set A, or it's equal. My dog's wanting to say hi. That's going to happen throughout these videos. Sometimes we need a proper subset in which we make sure that A and B are not equal. And so if they're not equal, we'll remove that line and we'll say that B is a proper subset of A, or B is contained in A. So let's look at the colors of the Olympic flag. We see a field of white with 5 rings that are blue, black, red, yellow, and green. This set can be written as O equals the set, right? The squiggly brackets, the braces, white, blue, black, red, yellow, green, into the set here. We can see that the colors of the American flag A, red, white, and blue, are a subset of the colors of the Olympic flag. And they're a proper subset, right? Because O has more than just A. So we could say A is a subset of O, but even further, we can say that A is a proper subset of O. All right, the set containing no elements is called the empty set. Now, the empty set has 2 main notations. One is a 0 with a line through it, and the other has a set of braces, right? A set with nothing inside of it. The first notation, sometimes used by computer scientists to distinguish the number 0 from the letter O. In this class, a 0 with a line through it is the empty set. It is not 0. It is not the same as 0. Empty set is nothing. 0, it means 0, but at least you're not negative, right? When it comes to money or something like that. The second notation literally shows a set with no elements. I prefer this notation, but I actually write this one more frequently. A finite set has finitely many elements. That is, there is no bound or end to the set. Excuse me, I said that wrong. There is a bound. I can't read my own typing, or end to the set. And an infinite set does not have finitely many elements. Right? It's not finite. My favorite finite set is the set of all even and prime numbers. It consists of the number 2. And my favorite infinite set is the set of all odd prime numbers. All right, I'll let you think about that one a while. So once we have a new item in math, sets, right? We have their members, the elements. What can we do with these? Well, set operations tells us that the set of all elements that are in common to both A and B is called the intersection of A and B. The symbol of an upside down horseshoe is used for intersection. It says A intersect B equals the set of all x such that x is an element of A and x is an element of B. So we see an intersection here, right? This is a regular street intersection. Let's look at the bike path. The intersection is literally where they overlap or where they cross, right? It's an intersection. Intersection in math, intersection in driving, exact same thing. The set of all elements that are either in A or in B or both is called the union of A and B. The right side up horseshoe, right, holding all the good luck. The U symbol is used for union. There's no tail on it. It's not actually a U. So we write A union B is equal to the set of all x such that x is an element of A or x is an element of B. All right, so or. And the union that most all of us are aware of is marriage, right? In marriage, you're setting up your house, you have all of your stuff, and you want all your stuff in there, and they want all their stuff in there, even that ugly furniture. And then all the stuff that you've bought together all goes in your house, right? It's A or B or what you've gotten together, all right? So union. If S is the universal set and A is a subset of S, then A prime or A complement is the complement of A in S. That is, A complement is the set of all elements not in A. Other notations for the complement include A bar and AC. All right, that C is generally raised, maybe lowercase, maybe capital, but these are generally the most common notations you'll find in mathematics. And A prime seems to be one that is probably the most common, but you might see it in other notations as well. A prime, A complement, is the set of all x such that x is not an element of A. We also have a cross product or a Cartesian product named after René Descartes. The cross product of two sets A and B is the set of all ordered pairs A and B with little a an element of A and little b an element of B. So we write A cross, and that's why I call it a cross product and not a Cartesian as much. A cross B is the set of all A, little a that are in A, and B are in B. All right, A cross B. Now, that's weird. Let's look at some examples real quick. If A, red, white, and blue, is the set of colors of the American flag, and O, white, blue, black, yellow, red, green, is the set of colors of the Olympic flag, then A prime is black, yellow, and green. Happens to be the set of colors in the Jamaican flag, but it's the set of all colors of O that are not in A. So here we have A, here we have S, our entire set that we're looking at, and here we have A complement, all right? All the colors of S that are not in A. Whew. All right. We could also do the cross product where we find A cross A prime, and what we do is we take a color from A, and then we take all the colors from A prime. So we'll take red with black, red with yellow, red with green. Red, black, red, yellow, red, green. Then we'll do the same. We'll do white and black, white and yellow, white and green. And then blue and black, blue and yellow, blue and green. So we could do the cross product by making ordered pairs. And we'll see these ordered pairs again later on in the course. That's all for this concept video. Thank you for watching. Be sure to watch the video of applications that accompanies this content and the one on Venn diagrams as well. It'll help you out with this section.